Hey guys, today we are looking at permutation. So 6A.1, I believe you need to copy these definitions down. So an outcome is one of the possible results of an experiment. An event is a possible choice resulting in an outcome. And a sample space is a set of all possible outcomes of an experiment. So for our first example, it says you build a meal with an entree, and that entree could be a pizza, hot dog, hamburger, or chicken. A side, chips, fries, or salad, and a drink. And you can choose soda or tea. Using a tree diagram, find the number of outcomes in the sample space. So this is something you've probably seen before, but a tree diagram is going to branch off all of our options. So here we have 4 options for our one entree. So we can choose pizza, we can choose a hot dog, we could choose a hamburger, or we can choose chicken. Then for every entree that we get the choice of one side. So if we choose pizza, we could choose chips, we could choose fries, or we could choose salad. So for each of these, we have those 3 options. Then for each of those, we need one drink. So if we choose pizza and chips, we could choose soda or tea. So soda or tea if we chose fries with our pizza, or soda or tea if we chose salad with our pizza. Same thing for each of these. So when we're looking to know the number of outcomes, we're looking at these bottom branches of the tree. So if we count all of these green bottom branches of soda and tea, we will get our total number of options. And so if I count along here, I get 24 different ways that I can make this meal with all of those choices. So the fundamental counting principle is kind of a shortcut to this, and you may have noticed this as you were trying to count your options. But if event A can occur A ways, and event B can occur B ways, then event A followed by event B can occur A times B ways. So complete example 1 using the fundamental counting principle. So all that means is we have 4 options for our entree, times we had 3 options for our side, times we had 2 options for our drink. So 4 times 3 times 2 is 24 ways. There are 24 ways that can occur. Alright, so in a high school, there are 273 freshmen, 291 sophomores, 252 juniors, and 237 seniors. How many ways can a committee be formed if one student from each class is chosen? So if we're choosing one from each class, there are 273 freshmen we can choose. There are 291 sophomores we can choose. There are 252 juniors we can choose, and 237 seniors we can choose. So we're going to multiply all of those. And we get 4, 7, 4, 4, 6, 5, 3, 7, 3, 2. So we get 4,744,000,000 different ways. If we want to choose one student, that is the total number of different combinations we can make. So a multiple choice test has 10 questions with 4 answer choices for the first 5 questions and 3 answer choices for the second 5 questions. And how many different ways could you complete the test? So for the first 5 questions, we could answer A, B, C, or D. There's 4 different ways. So 4 times 4 times 4 times 4. Because it doesn't matter how you answer the previous one, there's still 4 options for the next one. For the next 5 questions, there's only 3 different ways. If you want even a shorter way to write that would be 4 to the 5th, and then 3 to the 5th. We'll save you some time writing all of that out. So we could complete the test 248,832 different ways. All right, the last question says, how many 7-digit phone numbers are possible if the first digit cannot be a 0 or 1? So 7-digit phone numbers means we have 7 blanks here. So if we can't have a 0 or a 1, then 2 through 9, that's 8 options for the first blank. And then we have 10 different digits, 0 through 9, for the rest of those blanks. So 4, 5, 6, 7. So 10, 10, 10, 10, 10. Or you could do 8 times 10 to the 6th. And we get you'll notice we got 6 zeros there when we multiplied by 6 tens. So 8 million different phone numbers. All right, permutations. The number of ways our objects can be taken from a group of indistinct objects. So permutations are something where we care about the order that something's happening. So that's why it says that the number of ways it can be taken from a group of indistinct objects. So this is how we write a permutation, is a little n with a p and then a little r. So n is the total number of options that we have. R is the amount that we want out of that. And so the way mathematically we do this is using this formula, n factorial over n minus r factorial. And if you don't remember, we haven't covered what a factorial is. Factorial is like if I have 4 factorial, that means it's 4 times 3 times 2 times 1. If it's 6 factorial, it's 6 times 5 times 4 times 3 times 2 times 1. So you're multiplying every number smaller than that. Okay, so you have homework assignments for the weekend from 5 different classes. And how many ways can you complete the assignments over the weekend? So you need to choose from 5 different classes. We're not actually going to use this permutation just yet. So from your 5 different classes, for your first assignment that you complete, you have 5 to choose from. For your second assignment you complete, if you've already done your math homework, now you have 4 classes to choose from. You're going to complete all of them. So now for your third assignment, you only have 3 to choose from, and then you have 2 to choose from, and then you have 1. So you'll notice we formed 5 factorial there, 5 times 4 times 3 times 2 times 1 is 120 ways that you could choose to do your assignments. Okay, and how many ways can you choose 2 of the assignments in number 6 to do on Saturday? So that's where this permutation comes in. Because we have 5 assignments, we want to choose 2 of them. So you can type this into your calculator, or you can do the math this way. So n is 5, so 5 factorial over, and then we have 5 minus 2 factorial. So 5 minus 2 is really 3 factorial. So if I write this out, I have 5 times 4 times 3 times 2 times 1, but 3 factorial is 3 times 2 times 1. So these all cancel, and I'm left with just 5 times 4, which is 20 different ways. Okay, there are 12 books that you would like to read. How many ways can you line up 4 of them on a shelf? So you care about the order. There's 12 total. We want to line up 4 of them. So that means we have 12 factorial over 12 minus 4 factorial, or 12 factorial over 8 factorial. So this is 12 times 11 times 10 times 9 times 8 factorial over 8 factorial. So those cancel, so now I'm just left with 12 times 11 times 10 times 9. And I get 11,880 ways. Your band has written 12 songs and plans to record 9 of them. And how many ways can you arrange the songs on the CD? So you have 12 songs. How can you arrange 9 of them on the CD? So we have 12 factorial over 12 minus 9 factorial. So 12 factorial over 3 factorial. And we get 79 million different ways. Okay, distinguishable permutations is when a group of you have a group of n objects where one object is repeated q sub 1 times and another is repeated q sub 2 times, etc. So the formula here, we have n factorial over q1 factorial, q2 factorial. Let me show you, it's going to make more sense when you see an example. So it says find the number of distinguishable permutations of the letters in summer and in waterfall. So what that means is we have all these letters that we could rearrange in any number of ways. But if you have an M in one spot, it's not going to look any different than the other M, since there's 2 M's in summer. So we have 6 different letters, but our M's repeat, we have 2 of them. We don't have any other repeats there, so that's all we have to do. So 6 factorial over 2 factorial, which is 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. So 6 times 5 times 4 times 3 is 360. Now, in the word waterfall, I have 9 letters. I have A's that repeat twice, and I have L's that repeat twice. I don't think I have any others. So If I put that in the calculator, I get 90,720. Okay, so that's all I have for us for today. If you have questions, come in and see me. Otherwise, I'll see you in class.